Okay, here's the homework solutions. So the first thing is to take the dot product. So when you take the dot product of two vectors, you multiply the x components together and the y components together, and you add them. So we get 15, negative 15 plus 24, so that's going to be 9. So that's the dot product. Now the dot product can be either positive or negative. It doesn't have to be positive. Same thing for the second one. We got the dot product of these two vectors. So the way we would show this is 3i plus 4j dotted with 7i minus 2j. So if we're multiplying these two together, if it was just normal multiplication, we wouldn't have the dot there, but the dot means it's a dot product. So we multiply the two I components together, and we add that to the two j components multiplied together. We get rid of the I and j. The dot product is a scalar. So we get 21 minus 8, which is going to be 19. Okay. Use the dot product to find the magnitude of u. Well, the magnitude of u is equal to magnitude of vector u is just equal to the dot product of u dot u. Actually, the magnitude squared is u dot u. So if we figure out u dot u, we'll get a number, and we'll take the square root of that. So we have negative 512 vector dotted with negative 5 to 12 vector, dot the vector to itself. So you get negative 5 times negative 5 plus 12 times 12. So that's 25 plus 144, which is 169. So that's the magnitude of u squared. So the magnitude of u is the square root of 169, which is 13. So that's number 3. Same thing on the next one. So the magnitude of vector u squared is equal to u dot u. So we have vector 12i minus 16j dotted with 12i minus 16j. When you dot product these, you multiply the I components together, 12 times 12, and you add that to the j components. So that's 16 squared, which is I think is 256. But let me get my calculator just to be on the safe side here. Actually, that'd be more than 256. Maybe it is. Let's see. 16 times 16 is 256. Okay. So that says that the magnitude of the vector u squared is the sum of those two. 256 plus 144 is 400. So the magnitude of vector u is equal to the square root of 400, which is 20. Okay, find the angles between the vectors. So we have this formula that says that the cosine of the angle theta is equal to u dot v divided by the magnitude of u times the magnitude of v. And then once we have that, we can take the inverse cosine. So since we've done a couple of u dot v's here, I'm just going to show you how you would do it over here. So here we have u and we have v. So we multiply the I components together. So that's going to be 2 times 1. And then you multiply the j components together, which is going to be positive 6. So u dot v is 8. And the magnitude of u is going to be equal to the square root of 2 squared plus negative 3 squared. 2 squared plus negative 3 squared. So that's 4 plus 9. That's the square root of 13. The magnitude of v is the square root of 1 squared plus negative 2 squared, which is the square root of 5. So the cosine of theta is going to be 8 divided by the square root of 13 times the square root of 5. And that number has to be between negative 1 and positive 1. It always has to be, or if you've made a mistake. So that's 0.992277, blah, 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 blah. Okay, so theta is the inverse cosine of that. So we take the inverse cosine of the answer, and we get 7.13 degrees. And you kind of, if you look at what these vectors look like, or yeah, the vectors. So here you go 1, 2, 3, 1, 2, 3. So this vector is 1, negative 2, something like that, and the other one is 2, negative 3, which is going to be something like that. So it I expected a small angle, and it was a small angle. Okay, next one. So we've got u, this is number 6, u dot v. So we take 2 times 6, which is 12, and negative 1 times 4, which is negative 4. So we get 8 again. The magnitude of vector u is going to be the square root of 2 squared plus negative 1 squared. 2 squared plus negative 1 squared. That's the square root of 5. And the magnitude of vector v is the square root of 6 squared plus 4 squared. So that's 36 plus 16, which is 52. So we get the square root of 52. So the cosine of theta is 8 u dot v divided by the square root of 5 times the square root of 32. 8 divided by the square root of 5 divided by the square root of 32 is 0.6324, blah, 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 blah. And so we'll take the inverse cosine of that, and we get 50.7 degrees. Again, let's just kind of sketch this out, what this might look like. So the first vector is 2 in the negative direction, actually 2 in the positive direction, and 1 in the negative direction. So I'm gonna guess it like that. And the next vector is 6. So that's about, if this is 2, 2, 4, 6, and then we go 2, 4, 6, something like that. And that's the angle right there. It looks, yeah, 50 good. It's not unreasonable. And then, well, we got 2 more. No, we have 1 more. So this is number 7. So again, we have u dot v. So we have 2 times 4, which is 8, plus negative 3 times positive 3, that's 9, negative 9, that's, so we get negative 1 for that. And the magnitude of vector u is going to be equal to the square root of 2 squared plus negative 3 squared. So that's 9 plus 4 is 13, so you get the square root of 13. The magnitude of vector v is the square root of 4 squared plus 3 squared, which is the square root of 25. 16 plus 9 is 25, that's 5. So the cosine of theta is negative 1 divided by the square root of 13 times 5. Now this is going to be a fairly small number, so the angle should be close to 90 degrees. So we get negative 1 divided by the square root 13 divided by 5. So I get negative 0.0554. Theta is the inverse cosine of that. So I get 93.18 degrees. Okay, so let's sketch this again. So the first vector is going to be 2 comma negative 3. So that'd be 2 comma 2, 2 comma negative 3 would be something like that. Okay, let's do the other vector. It's 4, so that's 2, so 4 would be twice that amount. 4 comma 3, so it'd be probably like that. So you can see it definitely close to 90 degrees. It's actually slightly larger than 90 degrees. Okay, the next ones are to determine whether the two vectors are orthogonal, which means 90 degrees, parallel, which means 0 degrees, and or neither, which means it's either not 0 or 90. And so 0 degrees, the cosine of theta equals 1. 90 degrees, the cosine of theta equals 0. And anywhere in between, cosine of theta is greater than 0 and less than 1. And if it's negative, so if it's negative, then it's also not either 90. So what we'll do is we'll see if it's either 0 or 1, and if it is, then we know it's one of those two, and if it's not, then we can say it's neither. So all we have to do is just do the dot product, u dot v. So again, we multiply the x components together, and we add the y components together. So you get 72. So it's definitely not 0, and it's definitely not 90. So you don't have to actually calculate the angle, you just have to see whether it's either 0 or 1. And it's easy to figure out the 0 part. This has to be 0 for it to be 0. If it's 90, you'd have to divide, find out what this is, and then see if that's exactly what you get in the denominator as well. Okay, I don't think the next one is either. Remember, you can also think about the slopes of lines. So what I was thinking was just what these, I was just thinking about what this looks like. So this would be 315, which would be way up here. And this would be negative 1, 5. So that would be something like that. So you can definitely see they're not 90 degrees to each other. I don't think that one's 90 degrees either, but if you did u dot v, have 3/4 times 5, and the y part would be 1/4 times 6. So it's 3/4 times 5, or 1/4, negative 1/4 times 6. So you get 15/4 minus 6/4. It's definitely not equal to 0 or 1. So this one's neither, and this one's neither too. Just had to pick two that are neither. Okay, and the final one is the most difficult situation. And so what we're looking for is we were looking for the projection of u in the direction of v. Okay, the last two problems we're finding the projection of vector u in the direction of vector v. And this is the equation that we use. So we have u dot v over the magnitude of v squared. These are all scalars, and we'll multiply that by vector v. So for this first problem, u dot v, we take 2 times 6 plus 2 times 1, which is 12, plus 2, 14. The magnitude of v is the square root of 6 squared plus 1 squared, which is the square root of 37. So the projection of vector u in the direction of vector v is u dot v, which is 14, divided by the magnitude of v squared, which is 30 square root of 37 squared, which is 37. So we get 14 over 37. And if you multiply this scalar type each component of the vector, you get 84 over 37 comma 14 over 37. So that's the projection of vector u in the direction of vector v. Now to find w, which is the component of u that's perpendicular to the direction of v, all you have to do is take vector u and subtract the projection of u in the direction of v. So u was 2 comma 2 from this problem statement here, and the projection was 84 over 37 comma 14 over 37. So you convert 2 comma 2 into 74 over 37. 37 times 2 is 74. And so then we have 74 minus 84 is minus 10, so we get negative 10 over 37. And 74 minus 14 is 60, so we get 60 over 37. So that's the component of u orthogonal to v. This projection is the component of u parallel to v, or tangent to v. So I wrote this out. W is orthogonal to v. The projection of u in the direction of vector v is the component of u in the direction of vector v. And w is the component of vector u orthogonal to vector v. Okay, so we have another problem. This one here. U is this, v is that. So let me show you the results for that. So again, here's the equation. The dot product of u and v. So you take negative 3 times negative 4, which is 12, and negative 2 times negative 1, which is 2. So actually, the dot product of these two problems is the same. It's 14. The magnitude of v is the square root of negative 4 squared plus negative 1 squared, so that's 16 plus 1, 17. This magnitude squared is 17, so yeah, there should be a squared right there. See that I missed that out. So let me fix that. So that's squared. Excuse me. No, that's not squared. Why did I do that? Okay, so this is the magnitude of v and the magnitude squared. Okay. So now I just plug in the equation. This dot product is 14. The magnitude of v squared is 17. Multiplied by the vector v, which is negative 4 comma negative 1. Negative 4, negative 1. And then we multiply the scalar times the vector components to give us the final vector. So 14 times 4 is 56, and 14 times 1 is 14. So that's the projection of u in the direction of v. That's also the component of vector u, the component of vector u in the direction of vector v. W is the component of u orthogonal to vector v. I'm just going to call that vector w. So you take vector u, not vector v, but you take vector u and subtract the component of vector u in the direction of vector v. So it's -3, -2 minus this. And then I convert again these whole numbers to fractions with the same denominator as the second one. So 3 times 17 is 51. So -3 is the same as 51 over 17. And take 2 times 17, you get 34. And then you can do this operation. So we have -51 minus a minus. So we're going to -51 plus 56 is plus 5. So we get 5 over 17, comma. And then we have -13 plus 14. That's -20 over 17. So that is the W is the component of u orthogonal to vector v.